Okay. Okay. I'm gonna stream me following this article here, which is a little bit, I guess, old, so I'm not sure how far I can go with it. Basically, this is a Phoenix LiveView application that doesn't have a database, but rather relies on GenServer for state management. And the idea is that this is a note-taking app. So yeah, basically let me start going over the article. Okay. So yeah, back then, 2021, Phoenix LiveView is a new library that works with Phoenix and provides real-time user experiences with server-rendered HTML. The library documentation itself says LiveView provides rich real-time user experiences with server-rendered HTML. In this blog, we are going to harness the power and easiness of LiveView and GenServer. So what we are building, we're going to build a simple note-taking app with basic CRUD functionality. Its UI will be similar to the Notes app in macOS. I got this inspiration from the React.js crash course I did on Udemy. Styling is very much similar to the app in that course. A below screen recording is the entire flow of the project. This will give an idea of the project. Okay, so this is basically a Notes app. You enter a note here, a title and a body, I guess. Done. You have the list. You can also edit a note, and then you can delete a note. So basically CRUD, right? It's like create, read, update, and delete. So why GenServer? The GenServer is a process that has its own state. We're going to use this state to manage our application state instead of using the database. So typically when you create a Phoenix project, you get a database layer by default, right? It's Ecto in the ecosystem of Phoenix. So the equivalent of active record in Rails, right? So this is obviously not an ideal scenario to use a GenServer, of course. But the purpose of this blog is to introduce LiveView and GenServer usage. So action plan. So this is a two-part series. All right, so part one, this is it, right? Like we will be generating the application and we'll add the API layer and process layer. This is the GenServer. And then in part two, we're going to build the UI using LiveView and integrate the different layers we created in part one. So let's start. First of all, our system should have Elixir installed, and we can confirm this by running. Yeah, so we have Elixir. Let's switch to okay. Let me switch to this. All right. So basically, we're already here. Let me remove it. RMRF, node up. Perfect. So Elixir V, right? So we are running the latest version, 1.16.2. All right. And what's the next one? So once confirmed, we need to generate the Phoenix LiveView application, right? And we can do it with this command, right? So let's try it. Cut. Okay, so it's mix Phoenix new, node up, no ecto, right? This tells us that we don't need a database. And live is LiveView. I think that's default, but anyway, that's an older article. It's default nowadays. So it's asking us if we want to fetch and install dependencies. Yes. All right, so if we switch to the new directory, right, and we do mix server, just to make sure that the app is running fine. And yes, we can visit this URL, sorry, this, no, this, yeah, sorry. Continue. No. Anyway, sorry. Let's go again. So we can visit localhost 4000. Okay, so localhost, and we should see the current application running, right? It's an introductory page here. So let's leave this here just for we may need this. And sorry, this is what I was trying to show you previously. I cannot use this software, streaming software. Anyway, cool. All right, so probably nobody's here. Yeah, as always. Okay, so creating a node. Yeah, so we did that. Perfect. Navigate, ph. Yeah, we did that. Okay. Creating a GenServer, right? As promised in the introduction of this blog, we are going to create a process layer by using GenServer init. Create a file node server inside lib. Okay, so inside this, we should create this. So basically, lib node up nodes. Let's switch first, and then let's go here. Let's so yeah, ls node up nodes. No, there's no such directory. So basically what I want to do is touch lib node up nodes node server ex, right? Touch what? Oh yeah, I guess sorry. All right, and now I'm not sure if, anyway, so let's go back. Okay. Yeah, let's go. Yeah, inside the file, add the following code. All right, so let's do that now, right? So what was the file again? Node server. All right, basically add this. Just checking. Yeah. Let's save this and then let's return to the article. So use GenServer is a macro that adds GenServer behavior in this file, right? So it makes it a GenServer, I guess. The documentation says GenServer behavior abstracts the common client-server interaction. Developers are only required to implement the callbacks and functionality they are interested in. We are going to implement these callbacks and functionality. This will be our 4 basic CRUD operations, right? All right, so initializing GenServer. The GenServer has the function startLink, which is used to start the process. We are going to add our own startLink function. This function will start the process by calling the GenServer startLink, which takes some arguments. We will not be passing any parameter, so we will ignore the args parameter. Okay, so let's, I guess, yeah, let's do that, right? Come on. All right. So GenServer startLink takes 3 parameters. Module name here is the case. In this case, gives the name of the module. Okay, yeah. Empty list, since we initially, so this is the state, right? We don't have any nodes. It takes a list of options. We're passing name. So, all right. As soon as the startLink function is called, it calls init function as part of the callback call. So let's add it. All right. All right, let's switch to the article. It has 1 parameter. It is nothing but the initial empty list we created. This callback returns OK tuple with a nodes list. We can test this by opening ix-s-mix command and yeah, basically do this. Okay, let's try it. oh, we get back an OK and a PID, which is the process. This is the process basically. Perfect. This PID is nothing but the process identifier, which confirms that a separate process has been started by GenServer, which will have its own state. Okay. By pattern matching, we have assigned this process identifier to PID. This is a variable that we can use later. So if you may remember, we initialize our GenServer with an empty list, right? So we can confirm this by running this, and this should return an empty list. Let's double check. All right. Yay. All right, so implementing CRUD functions. We have already discussed we are going to have 5 CRUD functions. Now we are going to implement that. GenServer has 2 types of functions, client-facing functions and server functions. The above CRUD functions we mentioned will be client functions, which will be called from the UI of our apps. These functions will eventually call server functions. Both client and server functions are usually defined in the same, file, depending upon the complexity of the project. We can call the server by sending 2 types of messages. The call messages expect a reply from the server, and cast messages do not reply. Let's see one example of each. First method that we are going to implement is all nodes. As the name suggests, with all nodes we are expecting some answer from the server. So we will use call. All right. So this is what we have so far. So I guess, yeah, let's do this. Cut. All right, I think this is it, right? We need to define all nodes, PID, do, and GenServer call PID, then all nodes, right? Yeah. Now, cut. Now the line GenServer call expects a callback where we will be writing our logic to fetch data from the state. Oh, I see. So that's like handle all. All right, so let's do it. Cut again. All right. Let's add one method here, def handle all nodes from nodes. And this is basically a reply nodes. Cut. As we know, call returns the current state of the process, i.e. the list of nodes. Hence, the tuple is reply. We can test it in the console by calling node server all nodes PID. It will return the list for now, which is empty. Okay, let's try it. I guess yeah, sorry. Node server, all node speed. So first let's do this, and then again all right, so this works, right? Let's try another turn. No, sorry, another Ubuntu, second one. Okay, so this is Scratchpad ls node app and vim. Okay, and we want nodes, node server. Perfect. So let's go back and see. Yeah, similarly, we can use cast, which does not return anything and is asynchronous. So we will create the create node function, which takes map as a parameter and creates node asynchronously. All right. So let's do it. So this is client, this is server. I see. And the server side, let's say it's a handle cast, not call. So this is again a create node. It's pattern matching. Updated node. Add ID node updates nodes. Okay. So this is no reply. Updates nodes. Okay. In the callback create node is the atom to identify the callback with node. So create node is the atom to identify the callback with node. as the parameter that we got in the client function, and the second parameter nodes. Handle cast, yeah, I was missing the second parameter, sorry, just added it, no worries. This one, I didn't type it. Okay, so since it, yeah, this is the current state basically, right? This is the current state, this is the new node. Okay, let's do it. Now, since this is a cast, hence it is a cast, hence we return nothing. So that's why we have no reply here. All right, that makes sense. This is how we implement call and cast. Similarly, we are going to implement the rest of the functions. All right. Ooh, this is, wow. I guess I could also just copy everything. The indentation is a little bit whatever, but we don't really care. I'm copying everything, right? So let's go back, cat. Yeah. What can I do? I can oh yeah, sorry. G, yeah, go up, B, G, big, and paste the whole thing, then save, then maybe if I can mix format or something, let me check. Yes, Ubuntu again, scratch pad node mix format. Maybe if I go back, yeah, it's formatted. Perfect. All right, so hopefully we have everything. So it's client, how does it do it? Yeah, everything, like the client functions are grouped together, the server functions are okay, so let's cut managing, yeah. All right, managing GenServer by supervisor. Okay, so far we have added the process layer and tested the API, right? In real life applications, we don't want to manually start the GenServer and keep track of the PID and check process health and whatnot. So we will give this responsibility to supervisor. We are going to start the GenServer process as soon as our application boots up. For this, we are going to make some changes in code and make entry for node server module in the application EX file. Open the application EX file and in the function dev start, add node app nodes node server nil. In the line node app web endpoint. Okay. Let's do that. Where? Start. Okay, sorry. Start endpoint. All right. Perfect. Is this the only change? You will notice is a tuple where the first element is the GenServer and the second is nil. Nil is the value we need to pass to Starling, so we don't need any, hence it's nil. Okay, So we also need to make some changes in the client functions parameter of the GenServer, i.e. all nodes, create node, get node, delete node, update node. In the, like previously we passed PID as our first parameter to these functions, but now we can remove that code because our process is identified by module name. All right, so should we remove the client? Okay, should we? Think so. Okay. I removed the PID based on this. So testing, run the server. Okay. In the terminal, this runs the servers as well as the IEX shell. Now try initializing the GenServer by running OKPID. You will get an error. We're not sure if our GenServer really is running. Okay. What is the PID of the process? What would be its current state right now? Let's find out. Let's run. It's going to return the PID of our GenServer, which, okay, we can use to get the latest state. You can play with different functions. Okay, this is the end. Oh, okay, this is the end. Okay, so let's, yeah, I guess let's play with this a little bit and see how it goes. Cut. Go here. Run this. And yeah, we'll get an error. I don't know why. Yeah, there's no match. And it's already started. Okay, already started. So this is the PID, right? This is the PID 699. Perfect. So let's see if this will give us the PID. Yes, this is the same PID. Perfect. And what we can do is get a state. Empty list. Perfect. You can play with different functions in the API layer and check the state at every step to test the application. Oh, right. So what I can do is basically create a node, right? Let me see. Can I create a node? What's the API? All nodes, create node, node. All right, node. Create node. Hello. What is a node though? Anyway, the structure is unknown. Nope. Oh, a map. Okay, is it dead? Sorry. It's a map, right? And how does it know that? Oh, here. So creating a node, yeah, add ID. Oh, it adds the ID. All right. So I guess I'm not sure, like 100% sure, but let's try that. Or expected the map. Oh, what is? Oh, this is a tuple. What up? I need to, I guess, ask. Oh, yeah, totally forgot the syntax. What? I did not found. Is it what do you mean I did not found? First, let's see, does this work? Okay. So what about create node? Key ID not found. Maybe I need it. I don't know. So what about yeah, what if, oh, okay, what about a second node, right? If this is something too, Okay, so now, so it doesn't even matter, right? Can I do this? I don't know. No. Yeah, this is basically, anyway, something 3, all nodes. Okay, so let's try delete. Okay, yeah, the API seems like it's working. Let me try the second part tomorrow because it's getting late. And yeah, all right, thanks for watching.